So in this project, we use the Raspberry Pi Pico to act as a step counter, and the Pico reads the data from the accelerometer, and then it detects when a step occurs, and keeps it in a running total. Um, the total is kind of displayed in the using the LEDs, so each LED like kind of lights up as you increase the number of steps. And then the step count is also it's activated through the phone, so the phone connects to the Pico. You either write start or you type in hex 00FF00, um, which turns the LEDs green, and then it starts. The first bit of section here is just all the pins stuff. So the because the accelerometer uses I squared C, we created the interface using the pin 20 and 21. Um, and then the address for it is on where's the zero? That's the address for it. And then we also configure the button. So the button turns it all off and disconnects the phone. So we configure the button, and the button uses the pull-up resistor, so it reads high, and then reads low when pressed. So that's on pin 14, and then the LED strip is connected in on pin 15, and there's three LEDs. So the accelerometer, we first set it into normal measurement mode, because the data is a 16-bit, like the tree signed 16-bit integers for the x, y, and z. We only want really the z because that's going to give us the most consistent, like kind of read for our step. So we extract the z values, and then so that's done here. And then we also divide it by this value to for the gravity, so it's for the step because you have to take that into account. So then the LED helpers, so this provides the visual feedback for the progress. So 10 steps, the first LED goes pink. The 20 is the second LED goes pink. The third step, the third one goes pink, and then you can see 40 is blue, so on and so forth. Then the step detection logic. So it's based on comparing the measure the measured z-axis acceleration to a filtered estimate of gravity. The variable gz stores a low pass filtered version of the acceleration, acting as the baseline kind of, and then the motion is calculated as the difference between the live measurement and this filtered baseline. But these are just the parameters for like at the start. Um, and then we have like the Bluetooth kind of sections. Um, so it connects like these just the GATS kind of parts here, and then the UUIDs for the different services. So we have a service that starts it, and then you can read from it, and then just the actual service UUID. And then one of them you can also write to, so we have to have that included. Um, so the main loop, so this is for the steps. Um, this is to advertise. So when we go to advertise, it's called Pico Step Go. And then what it does on, um, if you give it a value, I guess, so it can reset, so it'll stop the count. So it sets steps to 0, and the LEDs go to red. And then status, start, obviously the start of it, stop, and then what to do. So this gives you, like, if I send in the 00FF00, this is what it does here. And then when the events happen, what to actually do. Um, and then the main loop. So in the main loop, first checks if the button is pressed. If it is, the step counter is reset and the Bluetooth disconnects. If it's in running, the it continuously reads the z-axis acceleration, updates the estimate of the gravity thing, and then evaluates whether conditions for a step are met. So this is where it's like it says if it is a step or not. Um, and then when a step is counted, the LEDs are updated. Um, and the new step count is transmitted to the phone. So yeah, thank you.